equals x squared minus 4 over x minus 2, such that f of x or y is to be continuous everywhere at any number. And we want to graph the old and the new function. Well, first of all, we have a rational expression right here for f at x, and we can see that if x is equal to 2, then the denominator would be 0. So we know that for this function, f at 2 doesn't exist. And so when we need to think about what does this graph even look like, we need to think about, can I factor the numerator to make this simpler? Because right now it's hard to graph a rational expression like this, but we do know that I can rewrite f at x. The numerator is the difference of squares, so I can write this as x minus 2, x plus 2 over x minus 2. And because I can cancel out the x minus 2 term, then it just becomes a linear function where the slope is 1 and the y-intercept is 2. So if I was to graph this function and I wanted a quick sketch, I would have a y-intercept at 2, and I would go up. So up 1 over 1, up 1 over 1, and this is where a hole would be at x equals 2. And then I would keep going. So it would be a diagonal line that continues in both directions with a hole at x equals 2. Now, because we have a hole in this function, it's no longer continuous. So in order to make sure that it's continuous, then we need to create a piecewise function. And we also have to think about, we could think about limits as well, right? We know that just from graphing this, right, we can see that the function is going to approach 4 from the left side and the right side. So we know that that's going to be the limit of the function, even though it can't equal that value. So we're going to have to take the concept of what would the limit be at that and apply it to our piecewise function. So we know that the limit, we can see from our graph, the limit as x approaches 2 of x squared minus 4 over x minus 2 is equal to 4, right? We can see that from our graph that we just sketched there. So when I'm creating my piecewise function now, I'll call it g of x. It's going to be a piecewise function where the function is going to be x squared minus 4 over x minus 2, which we know is the same as x plus 2. We saw that over there when x is not equal to 2. And in order to make it continuous, we need this hole to be filled in, so we need the function to be 4 when x is equal to 2. So that's how we get around the fact that this original function isn't continuous by creating that piecewise function there to make it continuous. So now it's going to be continuous at every single point. So if I was to graph this now on the Cartesian plane, I'm still going to graph my function as it normally would be, where I'd have the hole up here at 2, 4, and it would go up and down in a diagonal line. But because of this part, this x, the g of x equals 4 when x is equal to 2, I can go ahead and fill that in. So now the graph is continuous because there are no breaks in the graph.